Hello and welcome to this repair tutorial, and today we're going to look at a Rotel and the model number is RB1080 and this would be classed as a power amplifier. In terms of general specifications, continuous power output is 2 times 200 watts into 8 ohm speakers. Frequency response is 15 Hz to 100 kHz. Total harmonic distortion 0.03%, and then in terms of dimensions 430 wide by 139 high by 400 millimeters deep. Input sensitivity is 1.5 volts with an impedance of 32 kiloohms and then a weight of 16.8 kilograms. And then here with the top cover removed, you can see that this is an extremely busy amplifier. There's an awful lot going on in there. So if we just sort of step through from left to right and just talk through what we're seeing. So on the left hand side, this is the audio module for the right channel. And then you can also see towards the front the toroidal transformer with the bolt going through to the chassis. And then just in front of that, what you can see just to the right hand side is a smaller circuit board, and this is the trigger control circuit, and on there is a relay which, if the trigger circuit is enabled via a toggle switch on the rear of the amplifier, it will turn on and off the power to the toroidal transformer. But do remember that the on-off button on the front of the amplifier will override the trigger control. The trigger module, as I mentioned a moment ago, you have an input which can be triggered via a 12 volt signal, and then there's also a 3.5mm socket where you can connect multiple units. So in theory you have the ability then to turn on and off multiple units within your stack system. And then on the right hand side here you see the left audio module, and then you can see that what looks like a copper plate, and there's multiple wires all screwed onto there. So that is what we term as a common connection plate, and the devices which are underneath, or the components which are underneath there, are the large power supply electrolytic capacitors, and each one of those capacitors is rated at 15,000 microfarad with an operational voltage of 80 volts. Now if we look here from the rear of the amplifier, what you can now see is that we have both balanced and unbalanced inputs, and that there is also a switch on the rear just to select depending on the type of input connection that you're going to use. And then you can also see this small toggle switch, so this is for the trigger, and then the robust speaker binding post. You can also see the power input protection fuse, and then directly underneath there the power input socket. And it's interesting to note that this is a 3-pin socket. Some amplifiers, they only have 2, so you don't have an external ground connection, but in this case, for this amplifier, you do. Now, what was the issue when this amplifier came into the workshop? Well, I've already previously refurbished and serviced and also repaired a previous amplifier for this customer, and this customer has multiple units. So really to carry out the same work on this unit as we did previously. So the aim was, because the amplifier, had been in good service for quite a few years, was to look at these large power supply electrolytic capacitors and confirm if they required to be changed. And what I found was that when they were tested on the ESR meter, they were down by probably 20 to 30%. Also as well, we can see that there is a second problem. And what I've done is I've put a series of circles highlighting the issue. Now we've covered this problem in many tutorials, and it's related to this brown glue that during the time of manufacture they coated it around electrolytic capacitors, or really any components that they felt required additional mechanical strength. Now, the issue with this brown glue is twofold. First of all, as it ages, it starts to become conductive, and at the same time, it also becomes corrosive, and that's an issue. The reason being is that often when they put the glue onto the circuit board, they will accidentally coat adjacent components or wired link connections. So here you can see the same glue, but now it's on all of the circuit boards. So in this case, it's connecting multiple power supply connections. You can also see on this smaller power supply board as well. And then on this shot, you can see here that it's also coating another adjacent resistor and then also power connectors. And then on this shot here, we just took a side view of one of the audio modules, and you can see that it's covered in different areas. And then if we take a more detailed view, you can see here it's coating resistors, and it's also coating some of the diodes. And this wasn't just on these modules. As we look in detail here, you can also see that this is a side view of one of the modules. And what I've done is I've taken the photograph which just shows one of the issues around the smoothing capacitor. Now you can see just to the left hand side of the capacitor there is glue on this 100 ohm resistor. It's also just touching one of the signal diodes, and then you can also see these two links which are coming from the top area where you see the Sanken audio output and driver transistors. So you can imagine the issue, and this is the case where it's not if it will fail, it's only when. That's the thing that you don't know. It will always fail, because as soon as this glue starts to go conductive, then of course you have current flowing where you should not. And then as it starts to corrode away these components, they will fail. And then of course when components fail, they don't often just fail as an isolated component. The failure of a component in a circuit often results in other issues, i.e. additional components failing. And it could be catastrophic, where maybe you lose some of the audio output transistors, the emitter resistors burn out, etc. And then here what I'm showing you is this is the circuit board for one of the balanced and unbalanced inputs. Now you can see again there is glue all around those capacitors there, and also connecting to the multi-pin connector. And then on this shot here, this is the power supply for the balanced and unbalanced inputs. And there are two Zener diodes on there. They're 16 volt Zeners, and it's coated all of those as well. So you can imagine this is tracking both the positive and negative supply of that small power supply there. So that's not going to be good long term. So what I've done is I just worked through the amplifier systematically, and I just removed all of that glue. And then any components which were contaminated with the glue, I simply replaced them. So any resistors, any diodes, etc. So any corrosive effect which had already happened was not going to be an issue. And then here, when we look from the top, what I've done is I have replaced those large canister type electrolytics. Now, as with many electronic devices, as technology improves, often the physical size of the components will also change. So if you look at these electrolytic capacitors, and these are high quality, so they're 105 degree operating temperature, and they are Cornell Doublier Knowles, and the physical size of them is smaller than what was the originals. But because this common connection plate bolts to the top, I could use the existing clamps where they screw to the bottom of the chassis, and then it was a case of just drilling just a slightly larger diameter holes where you see the bolts going through, and then fitting the new bolts. I also as well made up new connections, because on the original capacitors the eyelets which were on the interconnecting cables were relatively small. On here they were much more substantial. And I also did an ESR check on the other capacitors. All of them were fine, they didn't require any of them to be replaced. And then here, this is the trigger control module, and you can just about make it out that there is a small white relay on there. So this relay is 12 volt DC coil, and what I've done is I've put the part number in the description for the video. And then after that work is done, the next thing of course is to align the amplifier. So we only have two channels here, and you can see that this extract from the service manual tells you what the correct bias setting should be. So here we must be adjusting it to 7 millivolts, and you can see that on each one of the circuit boards we either have to adjust VR601 and then on the other board VR602, and what we are doing is we are just measuring by the emitter resistors the DC millivolts, and that is based on the current flowing through the output devices. So here, this is the extract from the service manual, and this is the complete channel which you saw earlier with all of the glue on, and you can see both the input balanced and then unbalanced connection, then into the input stage of the amplifier where you have the long tail pair. You may have seen it on an earlier photograph. On these amplifiers, what they do is they match the gain of these small signal transistors, and then they put like a rubber cap on top, and then inside of there is thermal paste just to keep the operating temperature of the transistors as close as possible. But if you did start to see any DC offset appearing either positive or negative on the rear terminals, then it's these components here in the very early stage that you would need to replace. And again, it's not a case that you can just measure them and say, okay, this is the issue. Normally you will just block change them out. Just use your transistor tester just to measure the HFE, and then match them up. So here you can see the adjustment. This is the left channel, VR601, and all I'm doing is I'm just leaving the amplifier running normally for about 25 to 30 minutes because this is a larger power amplifier, and then I'm then making the adjustment until it's correct. So here you can see that this was the initial setup, and I'm across the test points there, and you can see on this channel that it was slightly low. That's not unusual because of course we've done the replacement of the large smoothing capacitors that you can see here, and it was just a simple case then of just making the adjustment on each of the channels until we had them aligned then to 7 millivolts. And also the DC offset was very, very low. What's interesting on this shot is that these are the canister type Rotel branded smoothing capacitors, and you can actually see the date code on there. Right at the bottom where it gives the batch number, you can see 0215. So what that's indicating is that that is week 15, 2002. So that's just the batch date code, so you know how old those capacitors are. And then here, just really to look at the amplifier with everything all done. So you can see right at the back there, brand new smoothing capacitors in. None of the brown glue, all has been removed. Everything then has been tested through. And of course the amplifier was aligned and the bias adjusting accordingly. And then the only thing that remained, of course, is just to leave the amplifier on test. Here the amplifier ran for 4 hours and there was no issue in terms of operation. And then finally the amplifier is thoroughly cleaned and then returned back to the customer. So that brings us to the end of this repair tutorial. So if you have any questions or you need any help or support, by all means email audioamplifierservicing@aol.com and I'll be more than happy to come back to you and provide any guidance or assistance that you may require. So until the next time, I wish you all the very best. Cheers and bye-bye.